Welcome back. In part 1, we discussed what probability is and experiment, sample space, and event. We defined events. And then we discussed the first 4 rules of probability. In part 2, we will continue with the probability rules of 5 to 10. There are 10 rules of probability. We will continue with rule 5. Rule 5, rules of probability number 5, it says that if event 1 and event 2 are mutually exclusive, and this is addition rule for mutually exclusive events. We indicated previously that when two events are mutually exclusive, both events cannot occur at the same time. Dili pwede magdungan. Thus, for mutually exclusive events, the probability of event 1 and event 2 is minus 0. Therefore, when you are dealing with mutually exclusive events, the addition rule assumes a different form, shown as rule number 5. Probability rule 5, which is addition rule for mutually exclusive events. For two mutually exclusive events, event 1 and event 2, the probability of event 1 or event 2 equals the probability of event 1 plus the probability of event 2. Now this means that if event 1 and event 2 are mutually exclusive, then probability of E1 and E2 equals something like this visually, where this is event 1, this is event 2, described mathematically as this in this equation. And as you can see, they have nothing in common. They are separate from each other. So, P of E1 or E2 equals P of E1 plus P of E2 minus the P of E1 and E2, which is equal to 0 if these two events are mutually exclusive. 0. So that it is equivalent to just this one. This. So technically, wala na siya kay that is already 0. Now let's continue with rule number 6. This is conditional probability. The probability that an event will occur given that some other event has already happened. This is conditional. This is conditional probability for any two events, which states that for any two events, E1, E2, the probability E1 or E2 is equal to the probability of E1 and E2 divided by the probability of E2, where P of E2 or probability of E2 is greater than 0. The probability rule 6 offers a general rule for conditional probability. The notation P of E1 and bar E2 reads probability of event E1 given event E2 has occurred. So, naguna dapat si E2, it has happened, E2. And this is, we're not talking about the probability of E1 occurring provided that E2 has already happened. Thus, the probability of one event is conditional upon a second event having occurred. Conditional ang E2. E2 must have already occurred for E1 to also occur. Example here. Of the cars on a used car lot, 70% have air conditioning AC and 40% have a CD player CD. 20% of the cars have both. So the question is, what is the probability that a car has a CD player given that it has an air conditioning? That is, we want to find the probability of a car having a CD given that it has an air conditioning. So here, remember in part 1 we talked about this kind of table which is one of the way to visualize the concept of probability. Here, CD, no CD, because it is 70% has air conditioning total. 20% of the cars have both CD. No CD, no AC air conditioning, and no air conditioning. Ang CD and wala CD. Always the probability is 1.0. So for the probability that a car has a CD given that it has an air conditioning is equal to P, which is 0.2 over 7, which if we divide 0.2 over 7 gives us 0.2857. Given air conditioning or AC, we only consider the top row, the 70% of the cars. Of these, 20% have a CD player. So 20% of 70 is about 20.57%. Now let's have a business application of conditional probability. Syringa Networks is an internet service provider to rural areas in the western United States. The company has studied its customers' internet habits. Among the information collected are the data shown in Table 4.7. 4.7. This is joint relative frequency distribution for Syringa networks. Here in rows is E1, event 1, event 2, event 3. Event 1 is less than 20. Event 2 is 20 to 40, while event 3 is greater than 40. And event 4 here is divided between the gender. Event 4 is female, and event 5 for males. The company is focusing on high volume users, and one of the factors that will influence Syringa Network's marketing strategy is whether time spent using the internet is related to a customer's gender. For example, suppose the company knows a user is female and wants to know the chances this woman will spend between 20 and 40 hours a month on the internet. So let E2, event 2, equals small letter E3 and small letter E4. This is a set. Equals the event where person uses services of 20 to 40 hours per month based on this table. Event 220, this is hours per month of internet usage, 20 to 40 hours per month. E4 has the set small e1, small e3, and small e5, which is this one. E1, what was that? E3 and E5. E1, E3, and E5. A marketing analyst needs to know the probability of E2 given E4. One way to find the desired probability is as follows. 1. We know E4 has occurred because it is a given. The customer is female. There are 850 females in the survey. 850 females. Here. 850 females in the survey. And 1,650 males. Of the 850 females, 300 use internet services 20 to 40 hours per month. Then apply Rule 6 as follows. Okay. P of E2 and E4, and this is where E2 and E4 intersects. E2 and E4 intersects here, which is 0.12, and P of E4 is 0.34. Is that correct? Here, the total. So 0.12 divided by 0.34, the quotient is 0.35. So there was 35% probability of E2. This probability that a particular female uses internet services for 20 to 40 hours per month. Now let's go ahead with rules of probability number 7. This is conditional probability for independent events. We previously discussed that two events are independent if the occurrence of one event has no bearing on the probability that the second event occurs. Therefore, when two events are independent, the rule for conditional probability takes a different form as indicated in probability rule 7. Conditional probability for independent events. For independent events E1 and E2, the probability of E1 given E2 equals the probability of E1 where the probability of E2 is greater than 0, and the probability of E2 given E1 equals P, the probability of E2, given that the probability of E1 is also greater than 0. As Rule 7 shows here, the conditional probability of one event occurring given a second independent event has already occurred, it is simply the probability of the event occurring. Another is rule number 8, the multiplication rule for two events. When do we multiply? Probability rule 8, or multiplication rule for any two events. For two events, E1 and E2, the probability of E1 and E2 equals the probability of E1 times the probability of E2 given that E1 has occurred. We need to find the joint probability of two events in the discussion on addition of two events and in the discussion on conditional probability. We were able to find P of E1 and E2 simply by examining the joint relative frequency tables. However, we often need to find P of E1 and E2 when we do not know the joint relative frequencies. When this is the case, we can use the multiplication rule for two events. Here's a business application class for this multiplication rule. To illustrate how to find a joint probability, consider an example involving the Real Computer Company, a manufacturer of personal computers, which uses two suppliers for CD-ROM drives. This was when CD-ROM drives were very popular. These parts are intermingled on the manufacturing floor inventory rack. When a computer is assembled, the CD-ROM unit is pulled randomly from inventory without regard Which company made it? Recently, a customer ordered two personal computers. At the time of assembly, the CD-ROM inventory contained 30 MAT-X units and 50 Kinix units. What is the probability that both computers ordered by this customer will have MAT-X units? To answer this question, we must recognize that two events are required to form the desired outcome. Therefore, let event 1 equals the event which is MAT-X CD-ROM in first computer, and event 2 as the event that it is MAT-X CD-ROM in the second computer. The probability both computers contain MAT-X units is written as P, or probability of E1 and E2. The key word here is AND, as contrasted with the addition rule, in which the key word is OR. The AND signifies that we are interested in the joint probability of two events, as noted by P of E and P of E1 and E2. To find this probability, we employ probability rule 8. P of E1 and E2 equals P of E1 multiplied by P of E2 given E1. We start by assuming that each CD-ROM in the inventory has the same chance of being selected for assembly. For the first computer, P of E1 equals the number of MAT-X units over the number of CD-ROMs in inventory, which is in this case equals to 30 over 80, which is when divided 30 divided by 80, the quotient would be 0.375 or 37.5%. Then because we are not replacing the first CD-ROM, we find P of E2 given E1 by P of E2 given E1 equals number of remaining MAT-X units over the number of remaining CD-ROM units, which is at after this operation, from 30 na minusan na mag-isa, 29 na lang. From 80 na minusan nag-isa, 89 na lang. So, 29 over 79 equals 0.3671 or 36.71%. Now, by Rule 8, the probability of E1 and E2 equals the probability of E1 multiplied by the probability of E2 given E1, which is 0.3375 times 0.3671 or 0.1377 or 13.77%. Therefore, there is a 13.77 chance that the two personal computers will get MAT-X CD-ROMs together. Here, visually, another visual representation of the probability. Computer 1, computer 2. There are two different CD-ROMs, MATX and QNX. The probability of MATX is 30 over 80, which is 0.37, and QNX is 50 over 80, which is equivalent to 0.625 or 62.5%. For the second computer to have MATX as CD-ROM also, which has 29 over 79, or 0.3671. You'll have to multiply these two numbers, or this one. Multiply these two numbers. These two numbers, you multiply these two probabilities, which comes to 0.1377. And here the probability of having QNX CD-ROM also on the second computer are also computed here. For the two computers having the same QNX CD-ROM, the probability is 38.77%, which is much higher, almost times 3, compared to the probability of both computers having MATX CD-ROMs. Tree diagram for the CD-ROM example. Okay, let's go ahead with rule number 9 for the rules of probability. This is multiplication rule for independent events. When we determined the probability that two computers would have a MATX CD-ROM unit, we used the general multiplication rule. It's rule 8. The general multiplication rule requires that conditional probability be used because the probability associated with the second computer depends on the CD-ROM selected for the first computer. The chance of obtaining a MATX was lowered from 30 over 80 to 29 over 79, given the first CD-ROM was a MATX already. However, if the two events of interest are independent, the imposed condition does not alter the probability, and the multiplication rule takes the form shown in probability rule 9, which is this. For independent events E1 and E2, the probability of E1 and E2 equals the probability of E1 multiplied by the probability of E2. Using the multiplication rule and the addition rule, we have an example here from Midland Accounting, where Midland Accounting prepares tax returns for individuals and companies. Over the years, the firm has tracked its clients and has discovered that 12% of the individual returns have been selected for audit by the Internal Revenue Service. This is the equivalent of the U.S. Equivalent of our BIR, or Bureau of Internal Revenue. In the U.S., they call it Internal Revenue Service. On one particular day, the firm signed two new individual tax clients. The firm is interested in the probability that at least one of these clients will be audited. Meaning their the accounting report would be examined for accuracy. That's audit. This probability can be found using the following steps. Step 1, define the experiment. The IRS randomly selects a tax return to audit random. Step 2, define the possible outcomes. Here, for a single client, the following outcomes are defined. A for audit and for no audit. For each of the clients, we define the outcomes as client 1, audit 1, no audit 1. Client 2, audit 2, no audit 2. Those are the sample space. Then step 3, define the overall event of interest. The event that Midland Accounting is interested in is event where at least one client is audited. Step 4, list the outcomes for the events of interest. The possible outcomes for which at least one client will be audited are as follows. Event 1, audit 1, audit 2. This is when both are audited. Both clients are audited. For event 2, A1 is audited and the other is not audited. Event 3, A1 is not audited and E2 is audited. Step 5. Compute the probabilities for the events of interest. Assuming the chances of clients being audited are independent of each other, probabilities for the events are determined using probability rule 9 for independent events, where P of E1 equals P of A1 and A2, which is equivalent to 0.12 times 0.12 or 0.0144. For probability E2 equals 0.12 times 0.88, which is equal to 0.1052 or 56, 0.1056 or 10.56%. For E3, probability E3 equals P of N1 and A2, which is equals to 0.88 times 0.12 or the same as this one, that's 0.1056. Now step 6, determine the probability for the overall event of interest. Because events E1, E2, and E3 are mutually exclusive, compute the probability of at least one client being audited using Rule 5, the addition rule for mutually exclusive events, where P of E1 or E2 or E3 equals P of E1 plus P of E2 plus P of E3, or kanas lang ang number, which is equal to 0.2256. The chance of one or both of the clients being audited is 22.56%, almost one-fourth. Now there's also this Bayes theorem. What is the Bayes theorem? As decision makers, you will often encounter situations that require you to assess probabilities for events of interest. Your assessment may be based on relative frequency or subjectivity. However, you may then come across new information that causes you to revise the probability assessment. For example, a human resources manager who has interviewed a person for a sales job might assess a low probability that the person will succeed in sales. However, after seeing the person's very high score on the company's sales aptitude test, the manager might revise her assessment upward. A medical doctor also might assign an 80% chance that a patient has a particular disease. However, after seeing positive results from a lab test, he might increase his assessment to 95%. In these situations, you will need a way to formally incorporate the new information. One very useful tool for doing this is called Bayes' theorem, which is named for the Reverend Thomas Bayes, who developed the specific application of conditional probability in the 1970s, in the 1700s. Letting B be an event that is given to have occurred, the conditional probability of event E1 occurring can be computed as shown earlier using equation 4.9, which is the P of E sub I given B equals the P of E sub I and B over P of B. The numerator can be reformulated using the multiplication rule as P of E sub I and B, which is equal to P, we distribute P of I times P of B and I, or I. The conditional probability is then P of sub I given B equals the P of E sub I times P of B or I or E sub I over P of B. The denominator P of B here can be found by adding the probability of the key possible ways that event B can occur. This is P of B equals P of E1 times P of B given I1 plus these ones. That will be iterative depending on how many of them. Now, we are coming to towards the end. Rules of probability number 10. Then Bayes' theorem is formulated as equation 4.13, where the probability of E sub I given B equals the probability of E times the probability of B given E sub I when all the sum divided by the sum of all those numbers, where E sub I is the ith event of interest of the key possible events, and B is the event that has occurred that might impact the P of E sub I. Events events E1 to event K, E sub K are mutually exclusive and collectively exhaustive. Now here's a business application for Bayes' theorem. The Quail Shampoo and Soap Company has two production facilities, one in Ohio and one in Virginia. These are states in the US. The company makes the same type of soap at both facilities. The Ohio plant makes 60% of the company's total soap output and the Virginia plant 40%. All soap from the two facilities is sent to a central warehouse where it is intermingled or mixed or combined. After extensive study, the quality assurance manager has determined that 5% of the soap produced in Ohio and 10% of the soap produced in Virginia is unusable due to quality problems. When the company sells a defective product, it incurs not only the cost of replacing the item but also the loss of goodwill. Malain man tong kapalit og low quality. Malain siya. The Vice President for Production would like to allocate these costs fairly between the two plants. To do so, he knows he must first determine the probability that a defective item was produced by a particular production line. Specifically, he needs to answer these questions. 1. What is the probability that the soap was produced at the Ohio plant, given that the soap is defective? The soap is defective is the second event. Then 2, what is the probability that the soap was produced at the Virginia plant, given that the soap is defective? Now in notation form, with D representing the event that an item is defective, what the manager wants to know is P, probability of the soap was manufactured in Ohio, given that it's defective. What is that probability? And another one is what is the probability that a defective soap was manufactured in Virginia? We can use Bayes' theorem to determine these possibilities as follows. Na siyang equation, we know that event D, defective soap, can happen if it is made in either Ohio or Virginia. Thus, probability of defective equals Ohio, the P of Ohio and defective plus P of Virginia and defective, where P of D equals P Ohio times P defective from Ohio and plus that. We already know that 60% of the soap comes from Ohio and 40% from Virginia. So, P of Ohio is 0.6 and P of Virginia is 0.4. These are called the prior probabilities. Without Bayes' theorem, we would likely allocate the total cost of defects in a 60-40 split between Ohio and Virginia based on total production. However, the new information about the quality from each line is that the probability of a defective soap from Ohio is 5% and the probability of a defective soap from Virginia is 10%. So, given this formula, we then substitute the values. 0.6 times 0.05 over zero point 0.6 times 0.05 plus zero point 0.4 times zero point 0.1. The result is 0.4286 for Ohio, and for Virginia it's 0.5714 or 57.14% from Virginia, damage from Virginia, and 42.86% from Ohio. These probabilities are revised probabilities. The prior probabilities have been revised given the new quality information. We now see that 42.86% of the cost of defects should be allocated to the Ohio plant, and 57.14% should be allocated to the Virginia plant. Note the denominator P of D is the overall probability of the defective soap. This probability is 0.07 or 7%. The 7% of all the soap made by quail is defective. Here. Example. The Tektronix Equipment Corporation has developed a new electronic device that it would like to sell to the U.S. military for use in fighter aircraft. The sales manager believes there is a 0.6 chance that the military will place an order, or 60% chance. However, after making an initial sales presentation, military officials will often ask for a second presentation to other military decision makers. Historically, 70% of successful companies are asked to make a second presentation, whereas 50% of unsuccessful companies are asked back a second time. Suppose Tektronix Equipment has just been asked to make a second presentation. What is the revised probability that the company will make the sale? This probability can be determined using the following steps. Step 1. Define the events. The events, in this case, there are two events, sale and no sale. Step 2. Determine the prior probabilities for the events. The probability of the events prior to knowing whether a second presentation will be requested are P of S is 60% and P of no sale, or P of N, is 40%. Step 3. Define an event that, if it occurs, could alter the prior probabilities. In this case, the altering event is the invitation to make a second presentation. We'll label this event as SP, second presentation. Step 4. Determine the conditional probabilities. The conditional probabilities are associated with being invited to make a second presentation, where the probability of second presentation, which would um, cause for a sale, which would result to a sale, is zero point 0.7 or 70%. And while the probability of second presentation with no sale is 50%. Step 5. Use the tabular approach for Bayes' theorem to determine the revised probabilities. These correspond to P of is given SP and P of N given SP. Or for sale it's 0.6774 and no sale is 0.3226. Thus, using Bayes' theorem, if Tektronix equipment gets a second presentation opportunity, the probability of making the sale is revised upward from 60% to 67.74%, which is a bit bigger, a bit higher percentage of chances of making a sale. So, to summarize, class, the basics of probability. In order to effectively use probability, it is important to understand key concepts and terminology. Some of the most important of these key concepts and terminologies are discussed in section 4.1, including sample space, dependent and independent events, and mutually exclusive events. Probabilities are assessed in three main ways: classical assessment, the relative frequency assessment, and subjective assessment. And the rules of probability. In summary, to effectively work with probability, class, it is important to know the probability rules introduced. Section 4.2 introduces 9 rules, including 3 addition rules and 2 multiplication rules. Rules for conditional probability and the complement rule are also very useful. Bayes' theorem is used to calculate conditional probabilities in situations where the probability of the given event is not provided and must be calculated. Uh, that's the end of the part 2 class. I hope you will take the time to review this lecture video so that you would understand it and be able to answer the quiz starting Wednesday.